Hi everyone, I'm continuing to work on Quadra V-Tech from Cyberpunk 2077. To move forward, I need to solve the problem with the doors. At first everything seemed cool, but after a while I started to like the door mechanism less and less. Now I'll explain what exactly I'm not satisfied with. First, the door opens in 2 steps. I'd like to make it in a way that the door slides back smoothly and quickly. This leads to the second problem, a very slow opening. And if I install standard glass and covering on the door, it will slow down even more. Plus there will be a heavy load on the electronics. The electronic components are actually a real issue here. Something is always breaking down and there's not much left from the original boards in the design. The mechanism itself, namely the rails, also undergoes a heavy load. They are of course not designed to pull a 20 kilograms door with such a large extension. There is considerable backlash. I'd also like to have manual doors opening, so that it can be easily opened and closed by hand, as well as with the button. I want finally to get into the car without any problems, but not do rain dances. I've come up with a lot of ideas and now I'll try to bring some of them to life. Firstly, everything needs to be dismantled. By the way, I also need another CNC machine, and if I remove the rails from 2 doors, I could assemble a fully functional machine. This time, I want to make a hybrid mechanism, where there'll be a main lever that will carry the entire weight, and a guiding rail that will take some of the load. Too bad that it's not a van, where I could install both an upper and lower rail, and even attach one to the rear fender. So I made a template for the main lever and roughly fitted it to the body bends. It's too soon to make it. At first I need to make joints for it. I couldn't find any ready-made solutions, so I'll make them by myself. The housing will be ground from a thick-walled pipe, and the bearings will be located at its ends. The center shaft for this housing was turned from a 25mm round bar. Threads need to be cut at its ends. Now all the components can be assembled together using such bearings. The result is a roller that resembles a bicycle bottom bracket to which crank arms are attached. I'll need 2 pieces for the design. The joints will be mounted on heavy-duty brackets. One will be welded to a previously made metal structure and the other will be bolted to the door itself. The lever will be bent from a thick seamless pipe. For now I'll weld 1 pipe for testing. The lever must be shaped so that it doesn't lie against the passenger or touch the body while opening. This structure will be enough for testing. Then I need to make a rail and rollers. I'll turn the rollers by myself from Caprolon, shaping them to fit a custom-made rail made from a steel strip. I'm not satisfied with ready-made rails from minivans and vans, as their doors are much thinner compared to Quadra, and their bend is not sufficient to pull the door out of the opening. My idea is that the roller should move along the rail by means of groove. Even if I bend the steel strip, the roller still moves smoothly over it. Another roller needs to be made so that they together tighten the rail and therefore do not slip off. When everything is aligned, the carriage glides smoothly along the rail, but when it tilts slightly, it starts jamming. Without any load it moves very smoothly on its own. In general, it's still unclear how it works. I need to make the rail and test how it functions in combination with the lever. Of course you can't leave the rail on top, it needs to be placed lower, in the threshold. Fortunately there is enough space there. I'll temporarily use a profile instead of the door, connecting it to the lever and the carriage on the rail. Unfortunately, it was unsuccessful. The rail has its radius, so the carriage needs a joint which for now was made of a bolt and a nut. Thanks to this joint, the carriage rotates along with the rail bend. That's why it always causes misalignment and the entire mechanism jams. If the rail was straight, I could do without the joint, and this problem wouldn't occur. Well, that was a relatively simple solution that didn't work. I'll have to try another approach with a more complex multi-roller carriage. I cut out such a detail from the plate, on which the bearings will be mounted. The main large roller will be made of plastic to reduce noise during operation. On each side of the main roller there will be auxiliary rollers. To test the carriage I need to make a rail for it. I welded the rail from 2mm plates. It should be welded carefully in spots, as any weld overlap inside the rail would affect the carriage operation. The auxiliary rollers won't work in this way, so I increased the spacing using washers. Now there's proper support. To prevent the carriage from slipping off the rail, I welded another strip suchwise. I added 2 more rollers from the bottom, just in case. The result is smooth movement, and now it's time to test everything on the vehicle. The difference compared to the first design is, of course, obvious. The only remaining issue is the length of the levers. The rear part of the door moves too far away from the body. I'll need to shorten the main lever so the door moves in parallel to the body. If I extend the carriage fastening, the rail needs to be extended beyond the bend, and it already gets into the cabin. Most likely, I'll have to cut the threshold. Now I'll try to shorten the main lever. Due to this, the door travel's slightly reduced, but there's still enough space to comfortably sit in the seat. Initially, I planned to replace the bolt and nut movable joint with swivel heads, but they have a relatively large backlash. Therefore, I turned this part and pressed bearings into it. What really matters is that everything works properly, not the way the detail looks like. Finally, I cut an opening in the sill and reinforced it with 2 shaped tubes. I also added a cover plate and screwed everything together. The rail was successfully placed inside the car's sill. So far, everything is running smoothly and seamlessly. Now I need to test how this structure works under load. For this purpose, the missing tubes should be welded to the main lever. Based on my estimates, the door will weigh about 20 kilograms, so I tested the system with that weight. Everything remained smooth, and the carriage and lever withstood the load. I need to add more weight. Reached 40 kilograms. And even so, everything works, but it would take a lot of force to move the whole structure, as everything is inclined. I also tested one thing. I applied a 20 kilograms load to a single point to induce misalignment, but the carriage and the lever withstood it. I'll use the same linear actuator as before for pushing the door out. The only change is that I reinforced its fastening and made the adjustment mechanism on the stem with a swivel head. I welded this support to the lever for it. I positioned it in such a way that it would not touch the seat and at the same time would not interfere with the metal structure. Now it runs on 12 volts and its speed, I'll remind you, is 24 millimeters per second. The speed can be easily increased by raising the voltage, but I'd prefer not to use converters again. We need to find an actuator that can lift the door effortlessly and do it quickly. Under load, by the way, the actuator is not tensed a lot. Another problem occurred. When power is cut, the actuator doesn't hold the weight and the whole mechanism slowly slides down. To counterbalance the door weight, I added a gas strut next to the linear actuator. Now the entire structure stays in place and I can use a weak high-speed linear actuator. It's time to hang up the door panel onto this mechanism. It'd be better, of course, to cut everything off the panel and weld a new frame again, but I've already glued the frame with sealant and the internal structure is also a pity to modify. So I removed the rails and cut part of the structure for the main lever platform. The joint bracket will have several adjustments so that you can place the door in the opening. When working on doors like these, I realized that adjustments are needed absolutely everywhere, otherwise, the door simply won't fit into the opening. And even if it does, it will inevitably shift by a couple of millimeters over time. The main lever turned out to be very sturdy, with no backlash at all, ensuring that the door isn't loose while opening. I also made length adjustment on the carriage attachment to the door panel, but it wasn't particularly necessary. But it'd be good to make an adjustment on the rotation axis in future. Now this structure can be welded to the door frame. It'll also be necessary to prepare some covering for this structure, for example, to print a cover for this lever on a 3D printer. It'd be great to have a 3D scanner for this purpose. Compared to the previous mechanism, this one is like chalk and cheese. I really like how smoothly and efficiently it works, and most importantly, it opens the door so quickly, almost like in a game. A linear actuator isn't even necessary for it to function. It would be fun to make it so that the actuator automatically connects to the mechanism and disconnects when you need to open the door manually. The door definitely needs a lock or retainer, because the linear actuator alone won't be able to keep it in the opening. I'll use a standard car door lock. I placed the lock fixing screw on a plate, then welded the plate to the door. For the lock itself, I had to weld a plate to the rear part of the opening. After several hours of adjustments, the door now closes perfectly. However, because there's a gas strut in the mechanism, it constantly wants to push the door out, so it doesn't close completely at the front. Having checked available traps and retainers for sliding doors on the market, I realized they wouldn't work for me. So I decided to install another lock at the front. At least I can be sure that the door is securely fixed in place. I really like how everything works now. It's motivating me to keep working on Quadra's project further. Since now I have two locks in the door, I need to ensure they open simultaneously. For this purpose, I'll use an electric lock actuator. I want to connect it directly to the lock without using the internal mechanism. To do this, I welded a ball onto the latch so that a pull rod can be attached to it. Fortunately, the fiberglass body is wide enough and there's plenty of space in the thresholds to fit all the components. I did the same thing with the second lock, although there was less space here, so I connected the actuator directly to the ball on the latch. Then I connected two actuators to a single button, so they operate simultaneously. Now I can test how everything works together. With a single gas strut, the door is semi-automatic. It opens by itself, but you have to close it manually, which is very easy to do, by the way. I also need to come up with a retainer lock to hold the door in the open position, as the door tends to fly out of the opening, and the only thing stops it is the rear fender. I also decided to check how easy it is to get in and out of the cabin. The boarding hasn't changed, and there's more than enough space in the opening to get in and out of the cabin. The main lever doesn't interfere at all and doesn't protrude beyond the door trim panel. I installed the linear actuator in place and now want to test how the door closes with it. I'm concerned that the actuator might not have enough inertia to slam the door due to its speed. It seemed good when the door closed the first time with 2 locks. While opening the door, I need to make sure the button stays pressed for a while, until the linear actuator pushes the door out of the lock. Otherwise, the lock may not fully release, causing the door to get stuck in the opening. The only thing that comes to my mind so far is a delay using a time relay. To enable both manual and automatic opening modes, I need to figure out how to disconnect the connection with the linear actuator. How to do this, it is still unclear. Of course, it's possible to install a lock actuator to pull out the joint mounting axis. To summarize, the new door mechanism works well in both manual and automatic modes. However, I personally prefer the manual mode due to its reliability. You can access the vehicle at any time. Additionally, by laying emergency release cables connected to the locks, it would be possible to access the car even with a dead battery. Generally speaking, I'm completely satisfied with the new door mechanism. If you liked it too, give your thumbs up, leave a comment and see you in the next part.